Our goal for today, for 2.1.1, how does it grow, is to translate between different representations of a function. Representations of a linear function are going to be things like a graph or a table or a situation or a picture, thank you, or I'm forgetting something, or an equation. So those are the four things: graph, table, equation, situation. We're going to focus today on going from a situation to a table, and also from a situation to an equation, and also table to equation. And the equation is kind of the key for us today. We want to start getting a handle on what an equation for linear functions look like. Does anybody know what the equation of a line looks like? Does anybody remember that from last year? Y equals something x plus something. Does that sound familiar? No? Yes? You're saying unfortunately? Do you remember what those two other letters were in there? What were they? Y equals mx plus b. Does that sound familiar? Oh, good. And if you've never heard that before, don't worry. We're going to introduce it. We'll pretend that nobody's heard it, and we'll learn it throughout this chapter. So we're going to be writing this style of equations actually today. So it sounds like some of you are already coming in with some prior knowledge. Let's see how we do today, and then we'll score ourselves at the end. All right, so we're going to switch gears and look at this, but keep that packet handy. We'll be using it in a little bit. We're going to kind of be doing some things a little bit differently now that we're getting into chapter 2 and you guys are getting the hang of how class goes here, okay? I've been giving you a lot of handouts. We're going to start doing more problems out of the book. Today, we're kind of go in between. So what I did is I took the words out of the book and I put them on a handout. We needed a handout anyways, and I figured might as well just put the problems on the other side. So we're going to be completing all 4 of these problems in class today. I will be walking you through and working with you on problem 1, 2-1. And then after we do that, that's going to take us about 10 minutes or so. After we do that, then I'm going to give you about 20, 25 minutes to work with your table partners to complete the rest of them, okay? So please make sure that you're paying attention as we go over problem 1, because you're going to be doing something very similar when you get to problems 2, 3, and 5 later on, okay? All right, so flip over onto the back side. They ask us in problem 1 to look at pattern A, and they ask us, what do you notice? So there is imagine these are tiles, and there's a pattern from figure 1 to figure 2 to figure 3. There's something going on. It's a consistent pattern. What are you noticing about that pattern? What do you notice? Okay. You're saying add 1 block to the left side stack and 2 blocks to the right side stack. Do you guys agree with that? There's some other ways there's lots of ways to say that, but I really like that one. We're adding 1 block on the left side stack, 2 blocks here. So if I color in my new blocks here, this was a new one, and then these 2 were also new. That makes it a little bit clearer to see. So, and then we added this was new, and these were new. So with that information, I'm going to give you a couple of minutes here. My challenge to you is, can you please draw figure 4, and then see if you can work backwards and find me what figure 0 would look like. All right, so take a couple minutes right now on your own. See if you can find me what figure 4 and figure 0 would look like. And we'll come back and chat about those. So I need to put 1 more on the left stack and 1 more or 2 more on the right stack. Is that what your figure 4 looked like? Did you have to go a little off the grid on yours too? Figure 0 is a little bit tricky. If we're adding 1 on the left and 2 on the right to go forward, what would we do to go backwards instead? We would remove, yeah. So I need to remove 1 on the left and 2 on the right. So I need to remove 1 on the left. So it must be this one. It's my only choice. And I'm going to have to remove both of these on the right. How many am I going to have left over for figure 0? There's only going to be 4 here. Okay. Can I get your attention up here? Could you please pause? If you're working ahead, that's awesome, but I don't want you to miss some important stuff. So we're going to move on. We have done part B. I'm looking at the front page. Part B says to sketch the next figure and the first figure, or the 0th figure rather. Part C says, by how much is tile pattern A growing? And where are the new tiles being added with each new figure? I think we've talked about that, haven't we? So part C, we're growing by how much each time? How many new tiles are we adding each figure? 3 new tiles. It says where are we put them? 1 on the left, 2 on the right. Okay, we got that. Part D, oh, you know what? They don't do this, but we're skipping. I'm putting in a new part C. Could you guys make me a little table here? This table is going to have your figure number. That's going to be your X value. And the number of tiles will be your Y. So we've got figures 0, 1, 2, 3, and 4. And to fill out the rest of it, you're just going to need to count up how many tiles there are in each of those. Spoiler alert, figure 0 has 4 tiles. Can you fill out the rest of that table for me, please? Oh, are you okay? That sounded painful. Okay. I couldn't tell if you hit your elbow. I hate that when you like hit right on the funny bone. Okay. Do we need to actually count up how many tiles there are in each of these? What would a shortcut be? We already know that we're adding 3 tiles on each time, right? So if I started with 4 and I added 3 on, that would get me to 7, right? 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. Were you guys able to make that table pretty easily? That's one of our learning targets. If I give you a tile pattern, do you think you can make me a table? Give me a thumbs up if you're feeling pretty confident with that. Yeah, all right, good. We crossed one of them off the list, guys. We just got one more target to go, and that's writing equations. Now, before we get into that, I want to answer the question from the front of the page, which is part D, and I'll just read it to you. It says, what would figure 100 look like? So if I kept this table going, all the way out to 100, could you tell me how many tiles there would be in that figure? And what would it look like? I certainly don't want to draw it. We're going to describe what it would look like because it would be huge, right? We would have a whole bunch. How many tiles would there be on the left-hand stack when we got out to 100? We're adding 1 each time we go up in a figure, and we're going to end up going up to figure 100. So there's going to be 100 tiles here. How many tiles are there going to be over on the right-hand side? 200. Why? We're adding 2 more for each 100. So 100 times 2, that's 200. So we got 100 here, 100 here, plus the 4 that we started with. Sorry, 100 here, 200 here, plus the 4 we started with gets us 304. We think there's going to be 304. And thank goodness they didn't ask us to draw it because we would need a really big piece of graph paper. All right, we're going to do the last part, and this is going to be the trickiest thing we do today, but I have a feeling many of you are going to master this pretty quickly. So please don't miss this. This is going to be kind of the more challenging thing we're going to do today. Let me get you a copy of our handout here. Our goal now is to write an equation for this. Thank you. We want to write an equation. And somebody mentioned earlier that they were familiar with the whole y equals mx plus b thing. It's going to look like that, but just go ahead and write down y equals blank x plus blank. One of our big goals for today is to be able to translate between a table and an equation. And I'm going to show you the cheat code to doing this right now. Actually, I'm going to ask first, does anybody know what number is going to go in this spot right here? Well, let me show you how we're going to find it. So this spot right here is going to be the change. So if I were to ask you in this situation, how much are we changing? You would say 3. We're adding 3 new tiles each time, right? And we can look at our table here and see from 7 to 10, what are we doing? We're doing plus 3. From 10 to 13, that's plus 3. From 13 to 16, that's plus 3. This right here is our change. So the amount you're changing by goes in this spot. And for this equation, it's 3. And then we need one more number. Bless you. And that other number that we need is the starting value. This number right here is going to be your starting value. I'm just going to write start value. What was our start value for this? So the starting value is always going to go with an x of 0. So when you look at your table, you'll look for where x is equal to 0, and that y is going to be your starting value. So we started at 4, so we're going to have a 4 over here. So the equation would be y equals 3x plus 4. What can we do with that equation? What's the point of having an equation? Yeah, we can recalculate how many tiles there are going to be in for any figure that we want. Now, you guys predicted that for figure 100, we have 304 tiles. I'm going to use the equation and check that. Y equals 3 times x plus 4, but we're doing the 100th figure. Does that come up with the same answer that you guys just gave me? 3 times 100 plus 4, that is 304, isn't it? Yep. All right. All right. Let's flip back over onto the front side. So we have now finished problem 2-1. I am going to now hand the reins over to you guys for the next 20-25 minutes. You're going to be working on problems 2, 3, and 5. For problem 2, you're basically just going to repeat what we just did for pattern A. You're going to do it on pattern B, though. So what we did was we figured out how it was changing. We drew figure 4 and figure 0. We made a table and we changed that table into an equation. That's what you're going to be doing for problem 2. When you get to problem 3, read the instructions. They give you an equation. You'll use that equation to fill out a table. And then problem 5 is basically repeating the same thing that we did in 1 and 2, but for pattern D. Okay. About 20-25 minutes. If you're sitting by yourself, I give you permission to move and work with another group. Otherwise, stay on your assigned seat and work with your table partners. I'll be around to answer any questions. We'll come back and discuss here in about 20-25. Okay, any questions? All right, ready, set, go. All right, so what I noticed, and you guys tell me if you think this is right, it seemed like we were adding 2 new tiles for pattern B. Is that what you're doing? So I need to add another one here and another one here. So, and that means to take away 2 tiles, I'm going to start with 3 and in my figure 0. So if I'm making a table with x and y, 0, 1, 2, 3, that should be enough for me. I got 3 tiles to start with, and then I add 2 more, that gets me 5. 2 more gets me 7. 2 more gets me 9. Is that what your table looked like? And 2 more gets you 11. I didn't go up that far. If that's not what your table looks like, go ahead and fix it. There's 2 important numbers I'm going to need to get off of that table. I need my starting value, which is 3, and I also need how much I'm changing by. I'm adding 2 each time. Those are going to go into my equation. So my equation is y equals something x plus something. we just got to remember which parts go where. The change is always going to be the thing attached to the x. My change was +2, so I'm going to put my 2 attached to the x. Starting value is the thing that's not attached to the x at the end. So 3 was my starting value. That goes out here. Right. If you were able to get that, then you've got the main piece of what we're doing today. I do want to give you answers to part D for those who got that far. The equation you would have come up with for D would have been what? What was your change in part D? How many tiles were we adding each time? We were adding 4 new tiles each time. And then how many tiles were there in the 0th figure? 1 tile in the 0th figure. So y equals 4x plus 1. Okay, let's go into our packets and get some notes in here. They've got a spot in your packet that says multiple representations web for linear relations. We have been learning about packet. I put the extras up on the top there. All right, I just want to get some quick notes in here to make sure we got this, because I feel like we're understanding it now, but chances are in a couple days when we come back to it, you're going to be a little bit rusty. So let's get some notes down that are going to help you get yourself back up to speed. So we talked about 3 representations today. Let's make a situation first. And the situation we dealt with today were tile patterns. I'm going to say let's stick with that and make ourselves a new tile pattern. So I'm going to make up a new one, figure 0 and figure 1 and figure 2 and so on. How many tiles do you want to be in our starting? How many of you guys want in the starting? 3? Okay, so I'm going to make, for figure 0, I'm going to make a pattern that has 3 tiles. I don't know. Be creative. However you want to do it. I'm making this one. That's my figure 0. How many do you want to add on each time? 1? We'll just do 1? Okay. So I'm going to add on 1 each time. So let me draw my original. And where do I want to put that 1? Bradley, do you have a preference? You want to put it over here or down here? Okay, anybody have a preference? Down here? It's kind of sort of makes a little bit of an S shape. Kind of like that. All right, so we added 1 more. So when I get to figure 2, then I should be adding another 1. So here's my original 3. And then we just added another 1, and now we're adding another 1 over here. That's probably enough for us to get the basic idea. So there's our tile pattern. Yours might look different from mine. I like it. Some of you are doing some cool creative tile patterns. One of our learning targets was, can we take a situation and turn it into a table? So let's practice doing that. Let's get that down in our notes here. So our table is going to have X's and Y's. The X is going to represent the figure number. We're going to call that our X part of our table. And the Y is going to represent the number of tiles. I'm going to make myself a nice, neat table this time, since this is our notes. I'm going to really try and neaten up my work here. My X values will start at 0 and go 1, 2, 3, 4. Ooh, I don't have enough figures to fill out my whole table, but I bet we'll be able to use a pattern. So just a minute ago, I asked you guys to show me thumbs up or thumbs down how you felt about making a table. Do you feel like you can do this? Give it a shot. Fill it out. You're just counting. How many tiles are there in our 0th figure? I count 1, 2, 3, so we'll put a 3 there. And in figure 1, I count 1, 2, 3, 4. And in figure 2, I count 1, 2, 3, 4, 5. And then once we get those, then we've probably got a pattern going that we can use to figure out what the rest of them are, right? What are we adding each time? We decided we were going to add 1. So we'll just add 1 again. We could make that go all day if we needed to. So there's our table. And since this is our notes, I think it would be a good idea for us to label the important things that we can find on the table. And the really important values that we need to do our next part are going to be the start value. Start value is always going to be where x is equal to 0 on your table. And the other number we're going to need off of this is our change. Our change is how much our y is going up or going down each time. And we decided to make our change +1. We got our situation, our table. If we've got our table and we can find those two important numbers, what's the third thing that we practice writing today? Equation. Let's do an equation. And what you guys learned and did a really great job with today was that the equation looks like y equals something x plus something. And those two somethings are related to the table. What's the first blank here? Is this the start value or the change? The change gets attached to the x. Our change was 1, so we're going to have 1x there, and I'm going to go ahead and label this the change, so I've got a little reminder later on. A couple of us made a really great mistake today and flipped the change in the start value in the equation. That's a super common mistake. If you made that mistake today, congratulations. It's like the most common mistake. You got it out of the way. Learn from it, and we'll move on and not make it again. This is going to be our start value. And for this one, it was 3. Yeah, great. So we got some nice notes there to kind of help us out. Later on, we're going to add in some notes about graphs as well. That's going to be our fourth representation. All right, you guys did a wonderful job today. Let's go back and just make sure we've covered everything. I'm going back to the front page of my packet. Learning target was to translate between different representations of a function, and the specific translations we wanted to do was situation to table. Do you feel like it right now, if I gave you a tile pattern like this, that you'd be able to figure out how to write a table for this? You can count tiles and figure out what's the pattern. All right, so we're feeling pretty good about situation to table. How about situation or table to an equation? Are you guys feeling pretty confident writing that equation, getting those two numbers in the correct spots? Go ahead and score yourself. I'm going to say that probably most of us are going to be in the 2 or 3 range, even if you totally get this, because you really haven't had a chance to practice it yet. Okay, so I would say most of us are probably going to be in the 2, 3 range, and then once you've had a chance to practice it several times, once you've done a couple of problems where you didn't have to get help or you didn't have to look at your notes, that's where I would move yourself into the 4 range. Okay, again, please make sure you've got your first and last name on that packet. And this is period 8, and you want that on both sides. And then we've got some time to start on our assignments. So let's talk about that.